Welcome. Today I'm going to be discussing how to optimize your structural design using Revit and RISA. My name is Debbie Penko. We're going to start out by talking about the different programs of RISA and how you might use those different programs and to bring those into RISA, from RISA's structural design over to Revit. It is a round trip process. We can bring information in different directions, and we'll discuss that as well. But I do want to talk about from the basics about how to bring a building over, and then we'll talk a little bit more beyond that, going into how to bring a non-building structure over, and then beyond that, how to do connection design. So we've gone through a long history here using structural modeling in RISA and tying it directly to your Revit model or your BIM model. So it helps to go from the modeling systems that you're using here in the structural side to tie it back over. The first learning objective I want to hit is going to be synchronizing your structural RISAFloor model and RISA 3D model with Revit. So that will be what we discuss as more of our building modeling tools. We have a building, we're talking about something that is going to be a building structure, multiple stories. We know that there's a diaphragm, we're carrying loads down the structure. That's a RISAFloor classic kind of model, and it does the gravity design. We'll take that over to RISA 3D. In RISA 3D, we'll do the lateral design. So we're going to first start with that. Then we're going to move over to RISAFoundation and bring over foundation elements over to Revit and see about what we want to do there. What are the tricks we need to do to make sure that we carry our foundation design over to Revit. And then we're going to talk about round tripping that full model back and forth between the different modeling systems. And then we'll go into how to get your steel connections from Revit into RISAConnection. So we have a lot of different methods, and the first thing here, I'm just going to start with talking about the different programs that we offer at RISA. So RISA 3D is one of our most popular programs. It's going to be your typical three-dimensional general analysis structural design tool. It gives us the ability to do anything from a roller coaster to a beam to a industrial platform to anything. It can be done in RISA 3D. RISAFloor, as I mentioned, is a building modeling tool. So we assume that there is an area load. We can do a floor by floor. That's why we call it RISAFloor, because sometimes that can be confusing, but it's floor by floor, which makes it helpful to look at a three-dimensional model one floor at a time. RISAFloor carries the loads down the structure floor by floor. So that's why we call it RISAFloor. And you're doing just the gravity design over in RISAFloor and taking the lateral elements over to RISA 3D for design of that. RISAFoundation also connects with these programs. So RISAFloor is where you might start your model, your building model, carry it over to RISA 3D, and then the two programs will send all of their loading for their reactions over to RISAFoundation for foundation design. And in RISAFoundation, we can do things like slab design, we can do grade beams, footings, pile caps, piles, retaining walls, all that is been in RISAFoundation. We have RISA section that feeds into RISA 3D. So if you have any section properties that are odd or built up, you can send those over to RISA 3D. So if something kind of an odd geometry that you're wanting to do a design or analysis on, you can send that over to RISA 3D. The other one we can do is RISAConnection. So that's a program where we can do steel connections, and it can talk between RISAFloor and RISA 3D to do connection design. So we're going to see how that fits into the equation when we're talking about Revit. So the first thing I want to do is talk about a building workflow, taking that model from RISAFloor over to RISA 3D and then to RISAFoundation, and then all of that information sent over to Revit. So I'm going to jump over to Revit here. I'll actually start at RISAFloor, for example. And RISAFloor, we can start in Revit or we can start in RISAFloor. I'm going to show you kind of examples of different situations. But in RISAFloor, if I'm looking at this model, I mentioned here this is a multiple story model. We have about 3 upper stories. So the roof level, 2 main floors here, and then we've got a concrete level below that. So I might call this a podium type structure. RISAFloor gives you the ability to do concrete levels like this as well as a beam supported floor. So if we jump into our beam supported floor, first thing you notice is that the red indicates that that's a lateral element, the blue is a gravity element. We lay out the floor system on a grid. That's a typical type of way you might build a model using a project grid. And we can see under that project grid here, these have members are going to be, if we look at the labels here, these are just going to be shapes that are going to be, for example, wide flange. RISAFloor is a design tool. So what it's doing is we tell the program we want to design a wide flange that fits into this criteria here. We put some area loading in the model. Some default area load gets applied to that structure. Right now, I'm applying some office dead load, some office live load. It's going to be reducible live load. There's a vibration analysis done for steel members here on there. And then we're going to have some dynamic mass that's going to go over to RISA 3D. So all of this is assumed on my office level. I also have a roof level. So I have different loading considerations for different areas for different floors. I can also apply just a point load in the middle of anywhere. So you can see I have right in the middle of my structure just a point load floating around. So you can do that anywhere in the structure in RISAFloor, and you can lay out different floor levels. They can be similar. This one here, I've changed the patterns just a little bit on the roof level, and then on the very bottom model here, I have a concrete level. So I can design all of this. I'm going to just start running my design for a second in the background. The program has load combinations that works off of, so the dead load categories, live load categories. It does a lot of this automatically for you using our load combination generator, so you can create these load combinations quickly and easily. The program is going through an optimization routine as it runs, so it's carrying all those gravity loads down the structure, finding the best possible solution, and then iterating a little bit here as it finds. So at the bottom of my screen you see the iteration of the solution, because when we think about design, the members get sized, then loads distribute slightly different, and we have to size things up and down based on those loads. So we're doing a full iterative design of those members, and we're seeing here each floor by floor gets carried down. The other thing that we have in RISAFloor that is going to be the diaphragm design. So we're seeing in the lowest levels, we're going to be doing some design on that concrete level, and the upper levels here, we're going to see we're doing the steel design. But if we go back down to the floor level down here, we can see that this is a full design based on the FEA analysis of that, so we can see any of the forces. We could get reinforcement design on this concrete level as well. But I'm going to go up onto my upper level and see a little bit more information here. In the steel level, we can see we get all of our wide flange designed with camber, with studs, with joint reactions. All that information is inside of this model here in each member. The reason why we're talking about Revit and RISA is what we really want to do is capture all this design information and send it back to Revit. Revit is interested in the parametric model or the parametric members here. So not just what the line item of this is, but what is the member itself, what's its material, what makes up that member, what's any of its design properties. So you can double click on a member in RISAFloor and see some information about it, some of its design properties. You can also go ahead and we have a detail report, which is helpful. So if you click on the word detail on the left side and click on a member, you'll find information based on that. So you'll see a little bit more about what's going on in that member. So it tells you specifically what's the axial, the shear, the deflection, tells you all that information. The end reactions, we're going to be taking those over to Revit. We've got, if we scroll down below, this is a composite member, so it gives us composite information. And then below that, we see any of the vibration analysis or deflection criteria that was just controlling the design. So RISAFloor gives us all that information for the gravity. The red elements are the lateral elements. So those elements are what we're going to do to take to RISA 3D. So using the director tool at the top of the screen, going over to RISA 3D, I'm going to take all this information. The diaphragm design here is going to be carrying across. So if we're going to be a rigid, flexible, or if we're doing semi-rigid diaphragm, all that's carried across, and we're taking this to calculate the wind loads in the structure. So each floor level is going to be using the main wind force resisting system to figure out what type of loading is going to be applied into that floor level. We can see a width and a length, and then calculates from that. We find a force in the X and the Z direction. So these two forces are going to go right into that floor level. Let's say OK. And the same type of information is listed here for seismic. So we tell the program specifically the seismic parameters of the structure at that location. And then it will calculate, based on that information, what is the period that's going to be used, and then we have a base shear. These are all based on these equations right here. And we scroll down and we can see that there's a force in the X and the Z direction, and that's placed into the diaphragm as well. So these are helpful. I like to print these out. These are good for your calc package, but I'm going to go ahead and jump right in back into here. Now you see it visually on the screen. So one of the things I like to see on my screen is a little bit about what the loading is on that. So we carried over our dead load and our live load, and we can see that right here. Sometimes it's hard. You see all that loading over in RISAFloor, but you never really see it in 3D. So if you ever felt uncomfortable, like, hey, what about the rest of my model? I want to know what's going on. It's still there. I just want to orient myself in my building. If you show yourself rendered, you can go over to miscellaneous and then say, show those floor items over here. And you'll see all the RISAFloor items just for reference, but you can see it gets really busy. It's hard to see in a three-dimensional model. So I like to turn that off. That was just a good reference to see it. And then we can see just the specific members that are the lateral elements that we're concerned with. So now we can see RISAFloor. We see all those RISAFloor elements that are lateral. And in here, if we kind of go back unrendered, we can see we have some moment frames, we have some braced frames sprinkled around the structure. We even have some shear walls around what maybe are like elevator shafts. We have all that listed there too. So all of that in our model, we would then create some load combinations to create that. But I mentioned that the model that the RISAFloor, as we go from RISAFloor to RISA 3D, the loads are applied in the structure as the wind load in the X direction, the wind load in the Z direction, and you can see it visually, and that really helps to understand what's going on in your structure too. You'll notice here you've got these point loads right into the structure. That diaphragm in my model is considered a rigid diaphragm on the upper level. The lower level is going to be a semi-rigid diaphragm. So it's going to just dump right into the middle of that diaphragm here for those rigid elements, and for the semi-rigid, it gets distributed inside of that diaphragm. You can apply those here. What we're going to do is just take a quick look at we have a load combination generator that I've already done in this model, but you can create all your loads automatically just by a few checkboxes. It will create all these different load combinations for you. So that includes all of our loads, our live loads, our regular live loads, our wind loads, the different directions, partial loads, and these can get a really long list, which is really helpful to be able to do it as a load combination generator. And you also can see all those loads right there in the basic load cases spreadsheet. So RISAFloor does all the work to put all those loads on the structure automatically for you. You can review those loads by clicking on any one of these little gray numbers. It'll expand and tell you what the number is listed there. So you can see it visually, or you can see it in the spreadsheet. Just helps to understand what load is on what. So I'm going to go ahead and run the model. I'm going to run a batch and an envelope solution. The only trick when you're using Revit is that when we drew in these braces, those braces had to be called a vertical brace. Revit needs to know that that's a vertical brace. It knows it's a beam here along that because it came from RISAFloor, so it's really smart about that. And columns also. RISA 3D is where you draw in those vertical braces. So we call that a V brace. If you had any kind of horizontal bracing, that would be an H brace. Walls go across just fine without any problem. It knows it's a wall. But Revit just wants to categorize things on how it is in the model. So now we can kind of see a little bit more information too. We can see if we look at, for example, our earthquake loads in the X direction, we can see that that also goes into the semi-rigid diaphragm down here, as well as into each diaphragm level here. So all of that's being designed. Once you've applied this and created all your different load combinations, you might then go into your design results. So it's a great spot to take a look at your design results. You can see what's going on in the code check. I like to highlight the whole code check and sort based on absolute max and absolute min to find out which is the worst case. Another trick we have in RISA that I really like this feature here, if I just look at the entire structure in isometric view, I can go to my design results and I can say, hey, all those design results that are failing, I want to see that on the screen. So I can highlight all those there and I can right click and say, unselect mark lines from current view, and then we might use the inverse tool, and those are the ones that are failing. We can also show this color coded too. RISA is a very graphical tool, so you can turn that into color coding and it'll show us any of the bending you need to check or what was causing that to fail. So we're looking here at a single results here. We can also look at, just by going back over to the members, we might show ourselves as the envelope results. And we see these are the envelopes results that are failing. Not by much, so you might want to size things up based on what they need there. A way to do that is a suggested design. And you look in suggested design and you can see that there are some shapes here that the program is suggesting we use. Some of them here are going to be at the top of the list already, but we find some of them are kind of lower, so we can let the program size things up or down. And the newer thing in RISA 3D is that now it's going to tell me if it's a strength criteria or if it's basing it on a deflection criteria. So RISA 3D also has the ability to base on deflection criteria too. So what I'll do is I'm going to size some of these up, say solve again. It asks me if it wants to do all of the members or just the walls, or I'm going to go ahead and do everything and solve again. Now RISA 3D is going into a full stiffness matrix solution again. So it's going to resolve, distribute the loads based on the stiffness, which means that things might shift slightly as one item gets sized up. The other one might change how much force gets drawn to it. Again, we're in a rigid diaphragm. So that means that these loads are going to be distributed based on the rigidity, so that can cause the results to change just slightly. So that's what happens when you do an iterative design. You solve again and again based on how the forces are now distributing and how they're sized. So we're getting a little bit better here. I'm going to sort this one more time in my design results and see. Still need to do a little bit more work on sizing things up, but I'm going to leave it at this point from here. So I'm going to keep going just for the sake of time. So we're going to go ahead and go now based on all of the joint reactions, so all of this information based on any load combinations that were created here in RISA 3D, all of that's going over to RISAFoundation. So I use the director tool and go over to RISAFoundation, carrying all these loads over to RISAFoundation, solving this, and it carries it by category. That's an interesting note for you. So everything in RISA 3D can be based on any type of category. When you bring it to RISAFoundation, we're now talking about concrete, and we're doing LRFD, which will have different types of factors on that. Maybe the same if you're doing LRFD for steel, but if you're doing ASD for steel, that would be okay, because we now have categories brought in over here, and those load combinations would be brought in based on the category. So that is something that comes across into RISAFoundation. In RISAFoundation, I see that I have all of my loads applied to the structure. If we look at this in isometric view, it's kind of an easy way to look at this, and you can sort this based on the categories. So jumping down to live load, we can see, for example, those ELX loads that we applied. We can see earthquake in the X direction, earthquake in the Z direction. We see all of that applied there. In the model I have here, what I've laid out is going to be footings. These are single footing designs. I have mat slabs. Okay, so I did that under the wall panels. I could do, for example, this one I tied two together. So I have a grade beam tying those together. But there's a lot of different functionality, and all this can be carried over into from RISAFoundation into Revit. We've added dual processing here, so it's going through all the cores in my program. I have quad core, it's running through all of that and solving it in much faster. So I see all of that solution took just seconds, which is great. And now it sizes everything in this model based on the need of what the loads came in from RISAFloor, RISA 3D. In RISAFoundation, we also have things like spreadsheet results, so you could take a look at any of the spreadsheet results, or you can click on a detail report, for example, to understand more about this footing, which it goes through details of the footings, including the load, soil bearing, and we see the different pedestal information, so we can see what's going on inside of there. We can also do things like our slabs, so we can see what's happening inside of that slab design. This gives us reinforcement design, and it tells us specifically what cuts governed for this one. So if I look at the cut report, I can see a little bit more about what's controlling for this one right here. So all of that here, as well as grade beams. Grade beams give you very similar results to what we see in RISA 3D, but we are seeing kind of that step there because what's happening is it's sitting on top of soil. So that soil is going to be having springs, which gives us a different kind of moment and shear diagram than we are used to maybe in RISA 3D. And at the bottom here, we get to see the detailing information of that. So the big trick on Revit here is not hard, but what you want to do is save your model. So save results. That's what's happening. This results here, why that's important is these footings are placed in the model but not sized until the solution is present. So you have to have that solution present, and then you're done. You can close your model and use the floor. And that's all it takes. We used to have to say file, export, things like that. We don't have to do that anymore with 2018, Revit 2018. So you can just close the model, and I'm going to jump back over here to let's go over to a Revit model. I've imported this for speed already because it does take a few minutes and I don't want to waste our time. But what I want to show you on this one here is how you would do it. So you would go into add-ins, import from RISA, and you can see in here that you have some choices on what to import. So you can import the model based on different project base points. If you want to say use a survey base point or the project base point, there's ways to adjust for that. You can use project north or true north. Update geometry sizes only, or you can update member sizes only. Now, if you are building a model from scratch, which is what I did here, you would want to say geometry and sizes. If there's a case where you have a model that you've already built and you don't need to do the geometry changes, you just want to update the member sizes, then you can just do that, and it will go quicker. But there's also times when, for example, something has changed in the model, in your analytical model, that you just don't care. You just need the sizes to come across. That might be a way to do that. So you can, this will sort of shortcuts any geometry changes. And then you've got the ability, so I'm going to say that there. We've also got walls. We can choose things to come across. Some of these things are pretty obvious. Obviously, we want to bring the walls across, and we can bring in the beam end reactions, which are really helpful, the diaphragms and the boundary conditions. To get those footings, you need to say that boundary conditions with footings. And like I mentioned, it has to have the solution file. Project grids can be helpful to come across, loads as well. Loads and load combinations are good questions of whether you do that. It's sort of a different system in Revit, so I typically leave these off and let the RISA model handle the loads, but you can bring those across. That foundation slab is important. If you want that to come across, you'll see that right there. ES is the concrete slab that we did in RISAFloor, and that's the elevated slab there, and that would need to have that checkbox turned on. And we can also bring in rebar for different elements too, columns, slab pedestals, and footings. And you just browse to find this file. Mine was located over here in my folder, and I brought it across earlier today. And then a couple other things we have from the advanced settings. We added in some of these things just to make life a little easier. With the different idea is that we are two different software packages, so there's ways we're going to handle things slightly different. But maybe if we can add some of these advanced tools in, maybe make the link a little bit smoother. So for example, the merge tolerance. You can set your merge tolerance there, and Revit has a different structural merge tolerance, so we can reset that for you too there. These two numbers are kind of we want to do to keep these things so that you don't pick up beam connections from other points. Merge tolerance is something where it can get a little things can snap to other things by accident if this merge tolerance is too large. We also pretty much always want to beam horizontally snap. That's a recommendation, but if you're in a problem, you can go back to a centerline type model. When you have a model that you're bringing across and you've already brought it to another model, you might want to clear any of those Revit smarts. Sort of, we're tracking through the link what's happening, so you might want to remove that there. So all of these settings here, including libraries, can be brought across. When you do bring that across right away, you'll see what we do create right there is a RISA import summary. And that brings this across like this, and it tells us if anything changed. In this model, I did change this upper floor, so you can see that those purple beams there are changed versus these are going to be new. So it's a nice way to indicate if there's a change to the system or if it's a brand new. The other thing, we can zoom in a bit and see like how those foundations came across. So RISAFoundation doesn't have an elevation. So foundations slabs don't have to be associated with the bottom of anything in particular. Footings are pretty easy. They kind of always sit at the base of a column. But for a foundation slab, it can be connected to multiple levels, things like that. So what we've decided is just to send it all the way to the bottom, and then you can scoot this up to the level you want it to be. So you would just increase that up there so everything slides up once you're ready to get that there. And place it underneath the wall that you're looking to set it under. So if we go into each floor level, you get the information that we saw over in RISAFloor coming across right into Revit. So when I click on a member, I have a lot of information in this member, including what kind of member it is, its material type. We see if it enables the analytical model right there, which we can also see in that analytical model. This is just what we have in RISA 3D. We think of this as the stick frame, the centerline analysis model. But if we're looking here in Revit, we're talking about this as the analytical model. So I click on that member and I can see a little bit about that information on that member. Below this, I see the end reactions. So start reaction to end reaction. If there was any moment in that member there, it would give me that information. We can also see here, let's look at the analytical beam. That tells me it's a gravity beam. It's connected to columns, and scroll down below that, it tells me it's pinned and any information on that. So you can see all of that type of connection information here too. All of these members here, then what I would recommend is starting to annotate them and working with them from there. So that's going to be your building modeling, and that's sort of similar why I really think RISAFloor fits so well with Revit is because it is thought about in the same type of way. Floor by floor, we're looking at that structure, each floor level, and then we're working on that floor level there. So that's so very similar to how we work in RISAFloor as how Revit works. Because really, that is the same thing. We're kind of all talking about a building model, which makes sense. But there is other types of models that you might run into. So I guess I want to just talk, the next one I want to talk a little bit about is RISA 3D. RISA 3D, you can also send your model from RISA 3D into Revit and back and forth as well. So I didn't take this model backwards there, but I'm going to take my RISA 3D one for you there. So I'm going to start this model, opening it up here in Revit. So this is a model in Revit that's a little bit different. It's going to be not your typical building model. So I kind of say that in a way that helps us understand when I say building, I'm talking about what we're sitting in, what the building that we're sitting in. The hotel type of building, the office building you're sitting in, any type of a building, where this is more of an industrial frame type of structure. I like this structure just because it's got a lot going on in it, and we can still see levels in it, but it doesn't have your typical, there's going to be probably B deck on here. It's not really going to be what I might call a diaphragm on this. A rigid diaphragm doesn't really fit in this type of structure. So it really is a RISA 3D model when I look at it. And I wouldn't take this to, for example, I wouldn't take this over to RISAFloor. I would struggle with, the problem is floor by floor. This would have some problems along the distances that these wouldn't be on a floor level and things like that. So we can take this structure over to RISA 3D to do. So I'm going to export this over to RISA 3D. And when we do an export, it's very similar to what we were looking at for an import. You pick the program you want to export from. So RISA 3D. I can tell the program to launch after export. Now, if you are not the person who owns RISA 3D, if you're sending it to somebody else, you can uncheck that. If you're in a demonstration version, you can uncheck that and then just reopen it in a demonstration version. So you have options here, but I own RISA 3D, so no problem for that. I'm going to launch it behind the scenes when I'm going. Export only selected items. So if by chance the whole structure is something you don't want to bring across, you just want to bring a portion of it, you could select an item in Revit. The way you select things is just kind of like you always select in another program. You just highlight it. You can just highlight those sections there, and then you would be sending it out like that. So anything in blue would be selected, and that can send over to RISA. So I'm going to send the whole model across, so I won't do that. The same options you have here, whether you're doing a different project north, things like that. We are bringing the analytical model across for RISA 3D. This fits really well for RISA 3D when we think about RISA 3D. This one has loads on it here, but RISA 3D is meant to be the centerline analysis, which is the same thing as what an analytical model is. So it really makes a lot of sense to do the analytical model when you're taking over to RISA 3D. That's how they talk to each other. We can send walls. We don't have any walls. Boundary conditions, sure. We don't have any of that. No problem. If you don't have it, it's not a big deal if you checked it on. And then I'm just going to send it into a new model called industrial. And I'm going to actually browse to a location. And I will call it, stick it in here. And it will be industrial example, but we'll call this 2, for example. And say open. And the other pieces you can do just like I showed you earlier. You can change some of the prefixes, the merge tolerances, some of the precisions, export only changed items. We're going to just say all over all items, no problem. And I can go from there. So I'm going to say OK. And it says, do you want to save that? And I'm going to say yes, save it. And it's launching RISA 3D in the background. We have a little ticker. This is not a large model, so it shouldn't take us much time. It's going ahead and doing all the things, and we can see if we had any errors, it would tell us there. It is breaking things into beams, columns, braces, and the materials. So I say OK, and it launches RISA 3D in the background. And it would, now I can open up the model, and it's going to tell me what's going on in this RISA 3D model. So in RISA 3D, everything is coming across. So if we look at our members spreadsheet, we see all the different members that were there. We see the materials that are there. All the materials come across from Revit. So we do have some default materials in RISA, but it does create some of the materials that it's bringing across from Revit, because Revit has some smarts in it for materials too. So all those things are coming across. We can see we could have changed the Revit I joints, J joints, things like that. But if you think about it later and want to do it later, you can do that too. If you say, hey, I don't like having this Revit name in front of that, you can go ahead and change that. You can go and relabel these joints. So just say relabel all joints using the N prefix, and it will relabel all those joints. And that I'm just used to seeing things more N because that's the default in RISA, so I might like that. But the Revit REV just helps me to see that it came from Revit. So either way you go, you can do things like that. It brought across the loads that I had. Let's see here. Looks like I must not check that, so that's okay. But you can apply more loads in here. You can do any type analysis in here. Let's just create just a simple dead load case let's just do gravity. So Y gravity -1. We're just doing self weight and counting just that one thing and seeing how everything goes across. And it says I didn't do P delta, but that's okay. There's some instabilities in that model. Not a problem. We can zoom in and see what's going on in there. Maybe just something is coming. Needs a little cleanup on that node there. But that's okay. It looks pretty good considering here that we brought this all pretty complex geometry across. We could look at, for example, again, the design results and see what's going on in here. But let's just do a couple different things here. For example, let's say that we want to change some of the geometry in the structure. For some reason, we do not want to have some of these these braces at the bottom. So I'm going to go ahead and delete some of these bigger braces, and we can change some of the geometry above that. So, do kind of a K bracing if we want to do something like that. So this is going to be a HSS 10 by 6 by 4. So let's go ahead and just draw in some kind of a different hot rolled. We go into a tube shape. 10 by, let's see, that was a 10 by 6 by 4. So something similar. Let's pick up a shape here. Close enough, and we'll call that a V brace, and we're going to be using that as material here, grade 50, and we'll go ahead and say this is pinned at both ends. So we'll go, one of the things on the three-dimensional, you easily see it can get hard to work in 3 dimensions, as I mentioned. So let's look at this in isometric a bit and maybe turn off my node labels so I can see. What I might click on is one of these nodes, and I'll just do a kind of a sub brace in here. So I connect this here from this location, and we're going to go back to, we'll just tie it off right here. So just sort of a K type of scenario back in my tower days, thinking about it like that. So go back to here and connect it to maybe over here. There we go. Okay, so not too simple, not too crazy, just a little bit of adding in some bracing. I just want to make a little change to it. We made a deletion, we made some additions to the braces, and the big thing I mentioned though, we did draw that as a V brace. That was a vertical brace. That's pretty important. Otherwise the program would be a little confused on how that would work. So now I'm going to save that. Like mentioned earlier, you can say export 2018, but you don't need to. And what you do that, it just says, hey, this is automatically done for you. You don't need to do this step. So we just kept it there for you just to remind you. And now I'm going to jump back into Revit. And I'm going to save this model one time, and I'm just going to go and say, okay, now import it back from RISA. So that was the industrial example 2, and import everything in their model, so including all of the information, update geometry and sizes. We can update everything in this model here, and beam reactions, sure, whatever you want, bring it all back from RISA 3D, and I'm going to say okay. And it's going to say save the model, sure. And it does like me to close down RISA behind the scenes. So I will do that. I'm going to go back into RISA 3D and close it. It's just so that happens so that you don't make a change, gets mistaken that it didn't happen. Sometimes we go pretty fast and we try to make changes in both programs at the same time while the import's happening. That could be pretty confusing. So we're not doing that there. We're trying to say, okay, close that program down, now re-import it. And it's going down and counting back all of these. The exchange file is smart. It knows, hey, 4 items were deleted. Those are the braces I deleted. 2 items were added. Some of the materials were added there, and that's okay. So when I say okay, this will now update my model from here. So it's going back into this model and saying, okay, what's going on? And this way, it does take a little second here in Revit. Revit's a very large, powerful program, but we can see it does take a second to do that. And in the RISA import summary we are looking at right now, it shows us here what was added. Those are the green elements that were added. And then you see that there's those braces have been deleted. And we're back to our model, working on our model now in Revit. So you can go round trip, round trip, round trip, whatever you want to do. It's sort of keep going around. It just can be helpful to, however you need to do that model. The next step I want to talk about, so that's your non-building type structure when you go into RISA 3D. And you can go in any direction. We started in Revit this time. You could start in RISA 3D. I showed you the other direction for the building type model. The next one I want to do is to talk about, so that's kind of the workflow of how you can go. The last piece is going to be RISAConnection. So I want to show you how this works. This workflow is a little different in that we are going to be talking about creating a model from Revit, whether it being coming from RISA 3D, from RISAFloor. It can do that, or it can just be a Revit model that you started there. And what you do is you create the connections, and then you send those connections over to RISAConnection. So Revit has a connection definition for any kind of 2 elements connecting to each other. We're going to probably focus on a couple different ones here, but we have design and size connections. You can send that to RISAConnection for design. So once you've defined the connection in Revit, you can send it over to RISAConnection. RISAConnection will check the code, the AISC or the Canadian code, and find whether it works. It will size things up. Any changes you need to make to that connection, you can send it back to Revit, and then Revit here will display those changes. The same thing here is for the project. If you have to make changes again to it in Revit, you can send it back to RISAConnection. So if anything in your project changes along the ways and you need to update your member loads, then that can happen, and you can just check what happens in RISAConnection and send it back to Revit. So it is sort of a different workflow because we're not, RISAConnection is just a piece of the puzzle. We're just doing the connection piece of that puzzle in this workflow. So I'm going to show you a model. Let me jump into a model back here. So if I'm going to close down these models and picked a simpler model just so we understand connections, because they can get also complex in 3 dimensions. So let me get to a simpler model and see that. In this simple flame model that I created, I've got a easy way for us to take a look at the connection design. And this model I did create in RISA 3D and brought it over. The reason I brought this over from RISA 3D, it will help me with my end reactions. However, you could build any model in Revit and put your own reactions into the model if you have it from some other location. So let me tell you a little bit about what that means here. So we click on a member in our model. I'm going to just jump over to our 3D view and click on for example, just looking at one of these members. If I click on that member, there's a couple different things that pop up. So first thing that pops up is a structural framing element. And if we scroll down below that, we see that we find a lot of information on that member, including the RISA information. So that RISA label is listed here. The RISA start and end reaction is listed here. The moment is listed here as well. And that's based on the envelope's reaction of what we solved over in RISA, and in this case RISA 3D. So we can use this information, and what happens is it automatically gets populated in the analytical beam section. So if we click on analytical beams, we can see a little bit further about what's happening inside of those member forces. And we'll see right here, this is a breakdown of all of the FX, FY, FZ. All of that information is broken down into here based on the fixity right there. You can also gain access to that if you, for example, didn't bring this from RISA. You can just drill down to the analytical model and put in your member end forces right here. So that's helpful for you if you want to start from a model that didn't come from RISA, or if however you want to, if you come across there. So I've got that showing here, and I have all that information listed in each member. So as I click on a member, I'll find that it has different information for a pin. I'm not going to have any moment. I'm just going to have here the shear forces. That's listed right there. And in this model here, let's take a look at what the way you would define a connection in Revit is using this connections here, structural connections. So it's on the structure tab, and if you look over here to this connections tab here, you have the ability to add in different connections. And using that little arrow, you'll see there's a lot of different connections that you can add into the to the model. So I've added a few, clip angle, moment end plate, shear plate. Those are the type of connections here I'm going to add into my model right there. And I've already added a few moment connections and sprinkled into my model. So if I double click on this connection here, we can see this is a moment end plate. That one here requires that you have the bolts pattern in as well as the weld described, and you can lay out the horizontal bolts, the vertical bolts, and that could be all placed on the end of a moment connection. So I've got that one in on both sides of this beam already. What I want to do is go ahead and put it into maybe some clip angles so we can see how that would work. So we'll go ahead and say we'll do a connection and choose, instead of a moment connection, let's do a clip angle. The way you define it is just to highlight the two and then press enter. So it has a connection there on that side, and we can scroll to the other side and do the same thing. So I'm going to say clip angle, structure, connection, highlight the two, push enter. And I now get a clip angle. So I can zoom in a bit and see that that's a clip angle right there. We can do the same thing maybe with a shear tab. So let's go ahead and choose, instead of a clip angle, let's shear a shear plate. Okay, so I can highlight the two, push enter, and it will add a shear plate to that. So we can zoom in and see that that's a shear plate added. And let's do that on the other side. So we do the same thing. We go to our structure, connection, and we're using a shear plate, and I'm going to highlight these two and push enter, and it gives me a shear tab on that one. So I've got kind of added in some connections throughout the structure, and what I want to do now is go ahead and send this over to RISAConnection to check it. So the add-ins tab, you'll see that there's an import and export connections. So we are going to be exporting RISAConnection over here. So we click on export connections. And the same options exist, so we can launch the program if we have it on our computer, which I do. So I will say launch the program. Export only selected highlighted objects, so I could do the same thing where select different things. I'm going to send everything over. Now you want to tell the program what kind of design code, since the loads we have in here are based on what either factored loads or non-factored loads. So mine are just going to say our ASD level loads, and we'll send that into a file format here that I create. So I'm going to browse and just call this a connection example. and we'll say that will be there. And now we can say OK. Now it's sending out these connections automatically. It's running through and finding the end forces and the connections and sending that to RISAConnection. We should see a summary report pop up really shortly. In that summary report, it's going to tell us information about what went across and what didn't. If there were any problems, it would give you a summation of that information right here. So ours look great. We put 2 connections of each type on each one. So we have girder to beam shear tabs, girder to clip angle, beam clip angles. We have some column to beam flush end plates there. So we can say OK. And it launches up RISAConnection in the background. Popping that open, I see I have lots of connections, maybe looking a little funny. But RISAConnection is really easy to manipulate these connections. So I typically do this here on RISAConnection side. Revit is a little harder to work with to make the changes of the geometry. I like to do it graphically, so that's a little bit easier over here. What we can do is first we can just take a look at how this came across. It groups things similarly together. So it found all the similar type connections together and grouped them into groups. And so what we first do is when we first start this model, we go into the project and say, run the whole project and tell us what passes and fails. So it runs through the code check of everything and says, did it pass or fail? And then it gives us a tally on the right side, fail, pass. I can see that listed there if it passed or fails. And then it gives us a code check in there with the load combination here that's governing. So ours are actually failing, but their code checks are under 1. So that always means it's a geometry problem. So we can start kind of addressing that one by one. So clicking on this here, we can click on the very first one that's failing, and I would click on this connection here and say, okay, well, why is this guy failing? And I'd like to sort of jump around into the different options first, but let's take a look at, first of all, 3-dimensionally. We can see what's going on in the model and see that it is a 3-dimensional model, and it allows us to click on anything in this model. So for example, I can click on the plate, and on the right side that plate section pops up. I can click on the bolts and they pop up on the right side. So if I wanted to make changes to the size of those bolts, I could. In the 2-dimensional view, the same thing works there. I could click on the beam and it pops up with the beam type there. If I click on a dimension, it'll show me that information there. But the root of the problem is why is it failing? So we go to the reports section, which is down here, and we can see under the reports there's a geometry restriction at the column and it's failing. All of these checks here are what the program is doing internally, and what's great about RISAConnection is if you expand any one of these by clicking on it, it will give you the full rundown of what's going on inside of that check. So we can see what was going on in the geometry check. We see here, there's a failure right there in the middle. It says check minimum edge distance failure. We are allowed to have 0.75 inches and we are at 1. So I would go over to my 2-dimensional view and pop into the front view. And it says that this number right here, this 0.75, is too small. So what I'll do is I'll just change that to be the minimum, which is 1 inch there. And now I can see if I can pass this check here. I may want to make this a little bit taller as well. That 0.5 seems a little tight for me to be able to put that bolt in. So maybe I'll put that at 1 too. So I have this at 1. I can get that in there, and now I'll check this one connection just to see if it works. And now it does pass. So we could kind of move on from there. So this end plate looks like it is okay. We may want to sort of finagle a little bit of that dimension there, but that's just, it's not code restriction, it's just maybe ease of construction, that if I click on that 0.5 and I highlight over here, I might want to make that a 1 as well. We can go over to this one, and gosh, these are tight, right? We can see exactly what's going on. This is a problem of too many bolts and not enough space. We probably don't even need so many bolts though, right? So we have a lot of bolts in here. So what I might do is click on the bolts and see that I have 3 bolts in there, and I only probably need 2. Okay, but what I'd like to show you on this group here is I can, instead of having to make the change on every single connection, I can go into my girder, my grouping of my girder beam clip angle and make the change on all of them. So I can click on that and I can go down to my girder bolts, and they're all similar. So I make a change in one place, say 2 bolts, and on that side there, that works there. I also want to maybe make some changes on the other bolts. The beam bolts, we'll make those to be 2 bolts per row, and now we have reduced the amount of beam bolts on either side, and I can solve that group one more time and it passes. We could make change, it's like probably 3/4 is too big. Maybe that could work, and I could change the bolts down to something a little bit more reasonable. Now I'm doing this in one place for the entire group, so it's kind of imagine I have a lot more connections. This might make this a lot faster. We still are passing, so we could take a look at what's going on in this. Maybe we start to decrease the size of this clip angle, but we can go through this and try to optimize this connection a little bit better. We have all sorts of checks happening in here, and those checks we can see further there. So same thing, if we looked at the girder to beam, we would see maybe that this shear tab has a little bit of problems because we have 3 bolts. So we might want to just click on that bolt and say instead of 3, we could change that to be 2, for example. And check it one more time, and it passes without any problems. So you've got this type of connection. We're doing a lot of different checks on these connections, including geometry restrictions, if there's any problems, erection stability issues, we can see that. So if I drop just 1 bolt, it will not pass the erection stability, but it does do all the bolt shear, the bolt plate block shear, a lot of different calculations for that one there. And what I really like to do is to understand those calculations. I can expand all of them so that I could print this out and send this to my plan check and go from there. All we have to do is just save this, and all that information we can go back up into Revit, and we would be able to import these connections, and it will just find that exact file where we have it, or if we need to change the location, and it will come back up inside right here. It's updating all of these connections, and we should see those change. The big piece was that you saved the file. That's the trick. Not much tips and tricks on that. You just need to save it, and then once it runs through these connections, it's checking all the geometry, anything that happened there, it can adjust from that, and we would see that these have been updated. We can say okay, and now when we look on that, we see that these are now showing here. These are going to be different bolts. I think that we've got, yep, there we go. There's our 2-bolt one that we changed. We can see those different numbers. I left one outstanding, but we see all that information here. This one is red. It's still failing. We had to adjust that one. We did not adjust that one. So we kind of left it, shows us a little bit of stuff of what's going on, and we can round trip from there. The nice part is if you had updates to the member forces, that could go back round trip, and it would go around and round for you. So let's jump back and kind of talk about all of the different things you've got here. So we went in a full round circle between Revit, RISA 3D was one of the first things we did, RISAFloor to RISA 3D to RISAFoundation, and lastly RISAConnection, sending Revit connections back and around round trip. And that's your full round cycle with Revit and RISA.